मैं डॉक्टर अशोक सैनी आज BA BSc 6 सेम के स्टूडेंट्स के लिए पेपर फर्स्ट रियल एंड कम्प्लेक्स एनालिसिस में फोरियर सीरीज पर लेक्चर दूंगा। फोरियर सीरीज, the introduction behind Fourier series is, in this chapter we shall discuss briefly the theory of Fourier series, which was first introduced by Joseph Fourier in the year 1768 to 1830. In studies connected with the flow of heat and the theory of oscillations in 1810. Fourier series is a very useful tool in the study of many physical phenomena with periodic nature. We begin by giving some definitions and standard results on definite integral, which shall be useful in our further discussions. Basic definitions which we will use in Fourier series is even functions. A function f is said to be an even function if f of minus x is equal to fx for all x and the graph of this function is symmetrical about y-axis. Example of even functions are cos x, x square, x cube into sin x, x square into cos x, etc. are all even functions. Second definition we will use is odd function. A function f is said to be an odd function if f of minus x is equal to minus fx for all x and the graph of this function is symmetrical about origin. The example of odd functions are sin x, x cube into cos x, x cube, x square into sin x, etc. are odd functions. Next definition we need in Fourier series is periodic functions, which are defined as follows. A function f running from R domain R to codomain R is said to be periodic if f of x plus some quantity, say lambda, is again equal to fx for all x belong to real number system, that is x is a real number and on lambda is not equal to 0. The smallest value of lambda is called the period. Illustrations of periodic functions are sin x, cos x, secant x and cosecant x are periodic functions with period 2 pi. Tan x, cot x are periodic functions with period pi. Sin 2x, cos 2x, secant 2x, cosecant 2x are periodic functions with period 2 pi by 2. Sin 3x, cos 3x, secant 3x, cosecant 3x are periodic functions with period 2 pi by 3. sin nx, cos nx, secant nx, cosecant nx are periodic functions with period 2 pi by n. Sin nx by L, cos nx by L, secant nx by L, cosecant nx by L are periodic functions with period 2 pi L by n. Remark: it should be noted that the sum of any number of periodic functions is also a periodic function. In this case, the LCM of the periods of all the functions is the period of the sum. For example, consider the series summation n running from 1 to infinity an cos nx equal a1 cos x plus a2 cos 2x plus a3 cos 3x plus so on. Here period of cos x is 2 pi, period of cos 2x is pi, period of cos 3x is pi by 3 and so on. As LCM, least common multiple of these periods is 2 pi, therefore period of the series summation n running from 1 to infinity an cos nx is 2 pi. Now the next we have trigonometrical series. A series of the form a naught by 2 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x plus a3 cos 3x plus b3 sin 3x plus so on plus an cos nx plus bn sin nx bracket closed plus so on. This series can be written as equal an equal a naught by 2 plus summation n running from 1 to infinity bracket an cos nx plus bn sin nx is called a trigonometric series, and the constants a naught, an, bn, n running from 1 to 3 so on are called its coefficients, which are real and independent of x. If the series converges for all value of x in the interval c less than equal to x less than equal to c plus 2 pi, then due to periodicity of the functions, its sum is a function f defined for all values of x with period. Some important results on integrals which we will use in Fourier series. If f is integrable on closed interval c to c plus 2 pi having period 2 pi and m comma n are integers, then first result about integral c to c plus 2 pi fx dx equals integral c to c plus 2 pi f of x plus a dx. That is, we can add a constant a. Still the integral remains same for any a real valued a belong to R. Second result which we will use is integral c to c plus 2 pi sine of nx dx. This integral is equal to 0, and also is equal to integral c to c plus 2 pi cos nx dx for n is not equal to 0. Third result about integral, important results. Integral c to c plus 2 pi cos mx product cos nx dx comes out to be 0 for m different n, and when m equal n, then integral c to c plus 2 pi cos mx cos nx dx equal integral c to c plus 2 pi cos square nx dx, and whose value comes out to be equal pi for n different from 0. Next results about integral we will use in Fourier series is fourth result, integral c to c plus 2 pi sin mx into cos nx dx equal to 0 for n is different from n. And fifth result, which we will use integral c to c plus 2 pi sin nx cos nx dx equal to 0 for n different from 0. Sixth result, we will use integral c to c plus 2 pi sin mx sin nx dx equal to 0 for m is different from n. And when m equal to n, then integral c to c plus 2 pi sin mx sin nx dx equal integral c to c plus 2 pi sin square nx dx is equal to pi for n equal to not equal to 0.